All right, hello everyone. This is Ms. Pi. Obviously, we are starting the first video for our next unit. This unit is all about patterns. We're going to look at several different patterns that you'll see in math, and then we'll describe them mathematically with formulas. Okay? Some of the stuff that we're going to go over, you saw last week when we were talking about finances. And this video is going to cover the first 2 pages and a half. I'm hoping to keep it pretty short though, because most of it is just definitions and terms and what everything means. Okay, so when you are looking for patterns, there's 3 different types of patterns that you can have. The first one is an arithmetic pattern, and basically, that is a pattern that is created when you're adding or subtracting by the same amount every single time. So like if I count by 2s, 2, 4, 6, 8, the pattern is arithmetic because I'm adding 2 to each number. Okay? Then there's a geometric pattern, and that's when you're multiplying or dividing by the same amount each time. So let's say I multiply by 2 every time, so I'd have, 1 times 2 is 2, 2 times 2 would be 4, 3 times 2 is, no, sorry, I'm totally messing that up. With geometric, you're multiplying or adding your previous answer by the same amount each time. So let's say our first term was 1, and our first term was 1. Well, 1 times 2 is 2. Our second term would be 2. And then we'd multiply 2 by 2, and we'd get 4. We'd multiply 4 by 2, and we'd get 8. Multiply 8 by 2, and 16, and so on. Okay? So geometric are a little bit more difficult, but you'll find that we've actually seen geometric patterns in our last unit about exponential functions. Okay? So when you're totally freaking out about your geometric patterns, just remember it's going to eventually be a exponential function. All right, and then the last category is just other. And so if it's not adding or subtracting every time, and it's not multiplying by the same number every time, then it's an other, okay? Now, other is, there's tons of different types of other patterns, okay? Think about the alphabet, A, B, C, D, E, F, G. That is a pattern, but it's not an arithmetic and it's not geometric, it's an alphabet, okay? There's lots of other patterns that we will see, and there's no hard, fast rule or formula for the other patterns. For the arithmetic and the geometric, we'll find very specific formulas to describe those patterns. All right, moving on. Okay, next section of your notes is there's several terms, and they want you to figure out what the 5th term is, and then an explanation on how you created the pattern or how the pattern was created. And then they want you to find the 10th term and then state whether it's an arithmetic pattern, a geometric pattern, or an other pattern. I'm going to show you the answers that are in blue. We'll do that together, and then I would like you to work on the others, the rest of these, on your own, and then we'll look at them in class tomorrow or on Monday. All right. So with this first pattern here, we have 16 to 23. And right here on the explanation they give it to us, they tell us you add 7 each time. So 16 plus 7 equals 23. 23 plus 7 is going to give us 30. 30 plus 7 gives us 37. And then 37 plus 7 is going to give us, 44. I think, let's see, yep, it'll give us 44. Okay? Hopefully you understand how we just continued that process. Okay, so if we keep on adding that, 44 plus 7 And then whatever that term is plus 7, whatever that term is plus 7. Let me see if I can do it in my head real quick. Give me a second. If you want to, while I'm trying to calculate this in my head, go ahead and grab a piece of paper and see if you can figure it out before I can. Let's see. 35, 79. I want to say it's 79. Let's see if I'm right. Yep, I am. Woohoo. I got it right. Go me. How did you guys do? All right. So now because we are adding each time in this case, we're adding by the same amount each time, then I know that it's going to be an arithmetic sequence, and I'm going to signify that with an A. All right, so the next one, we've got to figure out what the pattern is. And so I go from 16 to 8. Now if I subtract by 8, I'll get 8. Let's see if it's going to be arithmetic again. So I would subtract by the same amount each time. That does not equal, so 8 minus 8 which should be 0. So that doesn't work that way. So let's see if it's a geometric pattern, what it would be. Okay, so with the geometric pattern, ask yourself, what do you multiply or divide 16 by to get 8? And most of us realize that if you divide 16 by 2, you get 8. Well, so let's divide 8 by 2 and see what we get. Do we get 4? We do. Divide 4 by 2, we get 2. Divide 2 by 2, and we should get, that should equal 1. Let's see if we're right. And we are right. Okay? So what is the pattern, or how are we doing that? We are dividing each term, we're dividing each term by 2, or we can say we're multiplying by 1/2 or 0.5. Either one of those will work. It is totally up to you on how you want to write that. Okay? Now, to get the 10th term, let's see. I don't know if I can do this one in my head. I'll try. 4, 8, 16, 32, 64. I want to say it's 1/64. Let's see. Oh, I was off by 1. It's 1/32, or if you put that in the calculator, 0.03125, yada, yada, yada. So I was close. I was 1 off. All right, so now because we're multiplying by the same amount each time, we know that this is a geometric sequence. Okay? So now we've done an example of an arithmetic sequence, or arithmetic pattern or sequence, and then a geometric one. Let's look at the next blue one and see if we can figure out what we're doing here. All right, so I go from 1 to 4. Well, if I add 3 there, I get 4. Let's see if I can keep adding 3. Does that equal 9? No, it doesn't. So I can't, it's not going to be arithmetic. Okay, let's see. If I multiply 1 by 4, I get 4. So let's multiply 4 by 4, and I should get 16. So I don't have a geometric sequence either. Okay? Whoops. Let me go ahead and erase that. You'll find a lot of times the arithmetic and the geometric sequences are very easy to figure out. Some of the other sequences are more difficult. So because this is not geometric or arithmetic, I know it's going to be an other sequence. All right, so let's see, what are we doing to figure out or to get this pattern? Okay. If you notice here, 1 plus 3 gives you 4, right? And 4 plus 5 gives you 9. And 9 plus 7 will give you 16. So it looks like what we're doing is we're adding odd numbers. So if I continue this pattern, I should add 9 to 16, and I would get 15. Let's see if that pattern holds. Oh, not 15, 25. Thank you. Sorry. So 16 plus 9 gives me 25. So my pattern is holding. So this is what's happening is I'm adding odd numbers, and I'm not even going to attempt to do that in my head. Let me go grab a calculator. A lot of these odd patterns are very difficult to find out. All right, so I'm adding, I want to find my 10th term. So I'm going to, from 25, I'm going to add 11. And then to that answer, I'm going to add 13. Then I'm adding 15. And then 17. 1, 2, 3, 4. That's 4 of them. And then I'm adding 19. And I get 100. Wow, that's very surprising. All right. And yep, that's my answer. So I figured out the correct pattern, and I'm just adding by odd numbers. Let's see if the description that hey, look at that. Okay, so there's two ways that we were able, or we could have described this. We could add odd numbers to it, that's what we did, or we can square numbers. Okay, what they mean by squaring the numbers, let's look at this. If this is my first term, well, 1 squared is 1. My second term would be 2 squared, and that gives me 4. My third term would be 3 squared. Whoops. I'm doing the wrong lines down here. This is kind of intriguing. All right, so 1 for third term gives me 9. Fourth term would be 16. That checks out. Fifth term would be 25. And then the 10th term would be 100. So either way, whether you describe it as taking the square or doing the squares of each number or adding odd numbers, both of those will work. Now, so this makes me kind of curious what the next pattern is, because if you look, it starts out the same. You have a 1 and a 4, and a 1 and a 4 here, but the third term is different. So I want you to see if you can figure out the rest of these patterns on your own. Go ahead and pause the video so you can do that, and then move on. Okay, so this next section, a lot of times when you have your pattern, your arithmetic, geometric, or other type pattern, you'll have a formula, and it might not be readily apparent whether it's arithmetic, geometric, or other. So hopefully with this exercise we'll be able to recognize what type of pattern it is, and a lot of times it will help if you figure out the first like 5 or 6 terms in your pattern. Alright, so let's look at this first one. You have, let's see, 8n plus 3. Well, if n is 1, so my first term, I'm going to have 8 times 1 is 8 plus 3. That should give me 11. Okay, and then for my second term here, I have 8 times 2, so 16 plus 3 gives me, what, 19? Okay, there we go. And then for the third term, I have 8 times 3, so 24 plus 3 gives me, what, 27? Okay, and then for the fourth term, 8 times 4 is 32, plus 3 is 35. Okay, and so now I need to figure out what type of pattern is this. So if you just look at the formula or the expression, you may say, hey, you're multiplying by 8 each time, so the pattern is going to be geometric. Okay, but look at your terms. If I multiply by 8 each time, 11 times 8 would give me 88. Okay, so it looks like I'm multiplying by 8 each time, but I'm really not. What I'm doing is adding by 3. So if my first term is 11, and I add, not 3, what am I adding by? I am adding it, just not by 3. Let's see. 19 minus 11 gives me 8. So I'm adding by 8 each time. Sorry about that. So 11 plus 8 equals 19. 19 plus 8 equals 27. 27 plus 8 equals 35. So in this case, because I'm adding by 8 each time, the type is going to be arithmetic. All right, let's look at 16 and 17, and then I'll let you do the other two on your own. All right, for 16, we're plugging in a 1 for n, and so I'm going to have 1 in the numerator and 2 in the denominator, so it should be 1/2. And then 2 for n would be 2 in the numerator and 3 in the denominator, so 2/3. 3 for n, 3 in the numerator, 4 in the denominator, 3/4. And then the next one would be 4/5, right? Okay, so hopefully most of you have figured out that that is going to be an other type pattern. We're not multiplying or adding or dividing or subtracting by the same amount each time. That's an other pattern. And this one is a very common other pattern that you will see a lot coming up. All right, so the next one, the last one we're going to do together, 3 times 2 raised to the 1 power. Well, 2 to the 1 power is just 2, so 3 times 2 gives you 6. And then 2 squared would be 4 times 3 gives you 12. 2 cubed is 8 times 3 gives you 24. And then 2 to the 4th power is 16 times 3, let's see, 30, 46, 48. Yeah, 16 times 3, 48. All right, so with this one, let's see what we're doing. What do we have to do to 6 to get 12? Well, if you multiply 6 by 2, you get 12. What if you multiply 12 by 2? Do you get 24? You sure do. What happens if you multiply 24 by 2? Well, you get 48. So this pattern is going to be geometric. We are multiplying by the same amount each time. All right, sorry. Real quick, I want you to do the other two problems on your own. See if you can figure out what these answers are, and then figure out what type of pattern it is. All right. Let me see. I think this is one of the last things we want to go over. Different definitions in terms of vocabulary words. So a sequence is just, let me delete that. It's just a list of numbers usually in a pattern. Okay, so 2, 4, 6, 8, that's a sequence of numbers. Your symbolism that you're going to use for that are brackets or commas. Notice here, whoops, let me undo that. Notice here I have these little sideways mustaches or brackets, okay? And I separate each term by a comma, okay? Now, when I say term, what the heck am I saying? I've used that word a lot. It's just a number in a sequence, okay? If I say, what is the third term? Well, in this sequence up here, the third term is 8. Okay? It's just in one of the numbers in the pattern. Okay? When you are figuring or annotating that, you're going to do a letter or variable with a subscript. Okay? That's something that we saw with our finance unit when we were doing the balance. We said B sub 0 was the initial balance. Okay. Remember that from last week? B sub 0 is just our initial balance. Okay. And I think on one of the problems, I think it was equal to $1,000. So we said b sub 0 equaled 1,000. Okay? We're just saying that the first term was 1,000. All right, so what are we talking about when we get to positions? Is a term's ordinal location in the sequence. So first, second, third, fourth. Okay? That's what we're talking about. Usually in fact, in all of the problems in this unit, the n is going to represent which or the location of the term, first, second, third, or fourth, okay, and so on. Now, recursive, we've kind of talked about that last week, is a process of finding consecutive terms in a sequence based on a previous term. So, when we were paying off a credit card bill, we needed to know the previous month's term before we could know this term, or the next term, okay? And let's see, what did I do with that? Oh, okay, I know what I did. Down here, we have this pattern, or this example. We have a sub 1, our first term equal 2, and to find the next term, we're going to multiply our first term by 2. So in our pattern, we get 2, 4, 8, 16, 32, 64, 128, and then 256. So if we have a problem that has this situation, it tells us what is the 7th term, okay, we would just say it was 64 times 2, which is 128. And when we're looking for the 8th term, we would say it's 128 times 2, or 256. All right, so that's recursive, using your previous term, doing the math to get the next term. Okay, now with explicit formulas, you've got this case. You have your a sub n. Let's say I'm looking for the 8th term. I would have 2 raised to the 8th power. Okay, and then in the calculator, I just calculate that out. Okay, this time I'm looking for a sub 10, so the 10th term in this pattern. So I'd have 2 raised to the 10th power, and I'd get 1,024. If I was looking for the 14th term, I would have 2 raised to the 14th power, and I'd get 16,384. One thing that you're going to notice is when you are only looking for, like, maybe, let's say you only want to know the first 4 terms. It's really easy to do the recursive formula. But when you're looking for, like, the 10th term, or the 100th term, or the 1,000th term, it would be a pain in the butt to find all the terms before that. Instead, it would be really easy to say, okay, so let's say we wanted to know a sub 100. So my 100th term, it's much easier to say 2 raised to the 100th power instead of doing this huge recursive process 100 times to finally find my answer. All right. So I know this video was pretty long, sorry about that, but we went over a lot of information. If you need to, go back, rewind, listen to it again so you know all the terms and vocabulary stuff, okay? It will help you tremendously, and it'll save us a lot of time in class, and we can actually look at some problems in class and work on them together. All right, so I will see you Monday. Bye.